Okay, these are our notes for 8-6 sine and cosine ratio. This is similar to the tangent ratio, except it's a ratio of different sides. So again, it only works with a right triangle, except this time it depends if you're given different sides, different ratios. So we have our angle, we have opposite, we have hypotenuse, we have adjacent. The sine of an angle is the ratio of the opposite leg to the hypotenuse. Again, you're never going to get the 90 degrees, so don't worry about if they're the same thing. A cosine of an angle is the ratio of the adjacent leg to the hypotenuse. So you probably heard this before, maybe SOHCAHTOA. That's a way that people remember that sine is the ratio of opposite to hypotenuse, cosine is the ratio of adjacent to hypotenuse, and tangent is the ratio of opposite to adjacent. I have down here, don't spell it wrong. Please be careful, because I really do have people that will splash this down on their quiz and then spell it wrong, where they may put the A with the S instead of the O. So be careful. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. So when I move to the next slide, when we get to this triangle, remember all the tools in your toolbox for a right triangle. We have Pythagorean theorem, we have special right triangles, and now we have trigonometry. So when I go to this and I need missing sides, I might think first to look at Pythagorean theorem. Pythagorean theorem is good, but I don't have two sides, so I can't do Pythagorean theorem right now. And I don't have a special right triangle because 67 isn't a special right triangle. So instead, I'm going to use trig. That's my next option. Okay, let me just change my color here. So when I go to 67 degrees, I'll use that one. I'm going to look. I'm given the hypotenuse. So I'm going to use one of my ratios that has hypotenuse. For right now, I'm going to solve for x. So what is x to 67? X is opposite 67. So I'm going to try and find the opposite if I have the hypotenuse. So I'm going to use sine because sine is opposite to hypotenuse. So the sine of 67 equals x over 120. I'm going to multiply both sides by 120. Okay, and I'll have my little fancy calculator here. So I'm going to do 120, I think. Sorry. And I'm going to multiply that. The sine, oops, that's not good. Guess I'll find the sine of 67. I'm going to multiply that by 120. And I get about 110.5. So x is 110.5. Now, after that, you might say, well, I can use Pythagorean theorem now. It's not the best idea because look at how much rounding we had to do to get to the 110.5. And once we plug it in Pythagorean theorem, there's going to be more rounding involved. So I'm going to recommend that you do not use Pythagorean theorem unless it came out to be a whole number. So 67, I'm solving for y. Y is adjacent to 67. And I'm going to use the hypotenuse I was given. So I'm going to say the cosine of 67 equals y over 120. Then I'm going to multiply that, both sides by 120. Okay, so I'll come back to my calculator. I'm going to clear that. I'm going to say cosine of 67 times 120. You can see right here. And I get about 46.9. So you can try the next one. And then, so hit pause, try that one, and then come on back. All right, so if you did the next one with the 28-degree angle, you should have gotten that, I guess I should show you the work real fast. Sine of 28 equals x over 1,000. X will equal 470 roughly. And then you would have done the cosine of 28 equals y over 1,000. And you would have gotten that y equals 883 approximately. In the next one, we're going for angles. So same idea. Here's angle N. What are you given? Well, I have the opposite and I have the hypotenuse. Okay, so your question is, which trig function talks about the opposite side and the hypotenuse? And that would be sine. So we're going to go inverse sine here. Of 18 over 30, because that's the opposite over the adjacent. So again, we're telling the calculator, which angle goes with this side. So I'm going to do, hold on, let's clear this. Do the inverse sine of 18 divided by 30. You can see here, inverse sine of 18 over 30 equals about 37 degrees. So again, you can try the next one and push pause, try that, come back. In this one, 22 is adjacent to the n, 40 is the hypotenuse, so I'm going to do the inverse cosine of 22 divided by 40. And for that one, you should get, I believe that one was 57 degrees. Oh, not 75, sorry, 57. In the last example, we have a poorly drawn isosceles triangle with sides 8, 8, and 6. We're going to draw an altitude. So you can drop I'm going to drop this altitude first. An altitude goes from a vertex and is perpendicular to the other side. Now, I can prove this triangle and this triangle are congruent. HL, there's a couple different ways. Also, if you drop an altitude from the vertex angle, then it bisects this side. We've done this before. So when I look at this triangle over here, there's a lot of different tools in your toolbox again. First of all, you don't know any of the angles, so please don't assume this is a 30, 60, 90 or anything like that. I don't know what these angles are. But I do see that I know two sides of this right triangle here, the right triangle. So I'm going to use Pythagorean theorem. You could use trig too. There's ways to do trig. Be a little tricky, but so I'm going to use Pythagorean theorem and I get the square root of 55. Then I'm going to put this altitude in. Now this is a different story. It is not splitting this side equally because this isn't coming from the vertex angle. So I'm going to look at this blue triangle right here. And all I know about the blue triangle right now is that one side of it is 6. Oh my goodness, this is so poorly drawn. I apologize. Now, I can't use Pythagorean theorem. I don't have any sides. I can't use special right triangles. I don't have any angles. I can't even use trig because I don't know the angles. So we're going to come back up to here. And you can get this angle right here. Do you see how that angle is shared by the blue triangle and also by this green one? So in this green triangle, if I could get this angle, that would be the same angle as over here. They're the same thing. So I'm going to use my trig function here. And I'm going to use, okay, here's x. I have adjacent and hypotenuse. So I'm going to use the inverse cosine of 3 over 8. Oops, sorry. And that gives me a 68-degree angle. So now I know this is also 68 degrees. And I can use my trig now to figure out the length of this, which is the altitude. So I need this side. That is the side opposite the 68. I have the hypotenuse, so I'm going to use sine. The sine of 68 degrees equals x, that's this side over here, over 6. And when you solve that, you should get about 5.6. The altitude off of here will also be equal. If you need help understanding that, just let me know, and I can help you out why the blue and this altitude would be the same. And that concludes 8-6.